So the law of sines is really helpful when we want to determine the lengths or magnitudes of the sides of a triangle or the angles of a triangle. And in order to use the law of sines, we need to know at least the length of one side of the triangle and two angles. Here I have this generic triangle drawn. It has sides A, B, and C. Opposite from side A is the angle alpha. Opposite of side B is the angle beta. And opposite of side C is the angle gamma. The law of sines states that the sine of angle alpha divided by the length of side A is equal to the sine of angle beta divided by the length of side B is equal to the sine of angle gamma divided by the length of side C. And this law is very helpful when we need to use the triangle rule to figure out the magnitude of forces that comprise of resultant forces and their direction. So let's do a quick little example using the law of sines. For this triangle, I made the angle alpha equal to 60 degrees, angle beta equal to 40 degrees, and angle gamma equal to 80 degrees. Remember, the interior triangles or the interior angles of any triangle should always add up to 180 degrees, and in this case they do. So if side A would have a length of 10 units and side B would have a length of 12 units, what would the length of side C be? Well, we can use the law of sines to figure out what side C would be. In our equation above, notice that there are three terms. We do not need all three terms in this example. Most of the times you'll only need two sides, such as in this example. So if we use the first term and the last term, to solve this problem we could use side A, angle alpha, angle gamma, to determine the length of side C. So if we plugged in 60 degrees for angle alpha, 10 for side A, and 80 degrees for angle gamma, we could easily determine by algebra the length of side C. So the length of side C would be equal to 11.37 units.